Don't just copy. Hey, work and energy quiz. Energy is the ability to do work. What's the minimum amount of work that it would take for a 55-kilogram student to climb a 6-meter? Okay, we're climbing, we're lifting. You know what? Work is force times distance, but when you're lifting, it's really the force of gravity times the height. It's mgh. So it's going to be 55 times 9.8. Okay, guys, with me? Times 6. 55. Oh, turn the calculator on, Mr. Dueck. 55 times 9.8 times 6. I get 3,234. Although technically I should go to 3 sig figs, so I'll say 3,230 joules. If you didn't go to 3 sig figs, I won't freak out, but that's the trend in our final answers. 6 meters, that's about a flight and a half of stairs. So if you do a flight of stairs, you're burning around 2,000 joules of energy, give or take. Number 3 threw a lot of you. It's so easy that it's tough. Number 3 wants me to find total energy. Mr. Dueck, what's total energy? Look up. This is 2. This is 3. What's the total? What does total mean? Add. You want the total energy? I guess that's going to be all of the kinetic and all of the potential. It's going to be a half mv squared plus mgh. It's going to be 0.5 times, what's the mass? 2 times 5 squared plus 5 times 9.5, Mr. Dueck, 2 times 9.8 times 5. Can I do this in my head? This is going to be nearly 100. 5 squared is 25 times 2 is 50. You know what? It's going to be 100 plus a 25. You know what? I think it's going to be probably about 123 or 124. Mr. Dueck, why didn't you put an answer? Is it 124? Is that what it is? 123? 123? Why didn't I put 123 instead of, why did I go to 120? Hey, Valoria, how many sig figs? 2. How many sig figs? 2. How many sig figs? How many sig? Technically, my answer 2. So I rounded. Number 4 says, use the following graph of force versus position. Find the total work done moving an object from 0 to 5. Well, Mr. Dueck, work. Why can't I go force times distance here? Why can't I say, hey, the force is 200, the distance is 5. Why is the answer of 1,000 wrong? I have a changing force right there. The force is increasing. Force times distance only works for a constant force. Well, we had other definitions of work. Now the problem is, this is the only definition that's on your formula sheet, force times distance. The other two, Zach, you're going to have to commit to memory. But if you do the big review, I think you'll be okay. Work is the area under a force versus distance or force versus position graph. It's going to be this area plus that area. Area 1, it's a triangle, which is base 3 times height divided by 2 plus base 2 times height, length times width, really. Hey, you know what, Grayson? I don't think I need a calculator for this. Grayson, what's 2 times 200 in your head? So the answer is going to be bigger than 400. I would cross that one off. I would cross that one off. And I already said that 1,000 was wrong. What's 3 times 200 divided by 2? 300 plus 400 is? Were you able to do that all in your head? Okay. I would never damage your self-esteem. Now, I like number 5. I like number 5. I like number 5. And what I mean by that, Shaq, is I guarantee on your work energy test, I am going to give you some kind of a graph like this, and I'm going to say do something with it. So I don't know if it's going to be exactly like number 5. Number 5 says, okay, if the graph in question represents the work done on a 4 kilogram mass, find the speed when it reaches x equals 5 meters. The mass is initially at rest. A lot of kids, wah! Well, what did we find in number 4? Work. Now, work is force times distance. Work is the area under a graph. But you know what? Work is also the change in potential energy plus the change in kinetic energy. Rachel, this equation also, not on your formula sheet. This equation also, you could ask to Mary. Looking at this question, Zach, it doesn't seem to mention a change in altitude, a hill or anything, so I think I can safely do that. And what's change in anything? So this is going to be KE final minus KE initial. Oh, and it says it's initially at rest. So what I'm going to end up with then is this, a half mv final squared. Now that equals the, wait a minute, I don't actually need to put a W there. I know how much work was done. Grayson, what did you say the answer was for number 4? And they want me to find V final. I think times by 2, divide by m, and then how to get rid of a square root. I think V final is going to be that 700 times by 2, divided by the mass, which they told me 4, square root. It's going to be 2 times 700 divided by 4, square root 18.7. A. Number 6. Oh, power. Well, power is work over time, which is going to be force times distance over time. You know what? Actually, the work done, since an escalator lifts things, I think I can safely say, give me 1 second, MGH. Let me pause the video. Click. Pause. So an escalator lifts, I can go MGH. Time. Well, they were a bit sneaky. They said per minute. That went right through the line. Let's go a little lower. They said per minute. The time is 60 seconds. What's the mass? Well, it's 20 passengers times 60 kilograms each. 9.8 and 5. Oh, I think I can do this in my head because the 60s actually cancel. 5 times 20 is 100. You know what? It's going to be 980,000 watts. Is that right? See? So what we're saying here, Zach, is you need at least a 1,000-watt motor to get that many people through that escalator. I guess if you're doing 20 people in 60 seconds, it's basically saying 1 person every 3 seconds. In fact, I'll be honest, you need a bigger motor because that's assuming that this motor is 100% efficient. You probably need like a 1,500-watt motor or a 2,000-watt motor. What if you didn't have that? What if you only had a 600-watt motor? You could not get 20 people through in 60 seconds. You might only be able to get 10 people through in 60 seconds. Okay? Number 7, Mickey, you can switch back now. How much work is required to stop a 1,200-kilogram car moving at 10 kilometers per hour? Okay. Well, this is easy. Work is force times distance. Oh, wait a minute. They didn't give me a force or a distance. Oh, work is also the area under a force versus distance. They didn't give me a graph. So what's my third definition of work? What's the work energy theorem? And again, not on your formula sheet. Sorry, what? For some reason, I usually write potential first, but that's not wrong. It's just me. Eric, this question imply there's a hill or anything like, oh, you know what? Then I can go, what's changed in anything? Finest minus initial? It's a Freudian slip. You say one thing, but you mean a mother, right? Eric, are any of these 0? Now, it's going to give us negative work. I'm going to ditch the negative because this negative is not a direction. It's just saying the car needs to lose that much energy. So I'm going to give my answer as a positive, but I understand, hey, this is energy that's got to come from the car. This is how much work the brakes have to do. The brakes have to absorb it, mostly as heat. The car's got to lose it. It's going to be a half mv squared. It's going to be 0.5 times 1,000. Oh, you know what? I'm going to go 10 divided by 3.6. I do have to do a unit conversion. Squared, 1,200. What'd you get? A, B, C, D, or E? Is it B, I think? Now, before you turn the page, 10 kilometers per hour, is that very fast? No. We're going to start to be talking about collisions in the next unit. If you got hit by this car, probably you could absorb that much energy without dying. Maybe hospital, maybe break a bone, and bone force times distance, that actually would absorb some of that energy, which is kind of what bones are partly designed to do. Your collarbone, for example, is the circuit breaker for your spine. If you go falling forwards and you land really hard on your hands, the collarbone is designed to snap. Otherwise, all that energy gets transferred to your spinal cord, which you really wouldn't want to snap. So our bodies have, we've evolved some good safety systems. You'd survive. Wouldn't be pleasant, but probably you'd survive. Tarzan. Using the following, okay, Tarzan, 75 kilograms, swings from his vine from a height of 2.5 meters above the ground. At the end of his swing, he's only 2.4 meters above the ground. So I guess he lost some energy to like air resistance, let's call it air friction and heat and stuff. Oh, fact, A says, how much work is done by friction? Now, I know this question is saying how much work, but I really think our best approach is going to be, is there a change in height? Jack? Is there a change in speed? When you swing on a swing, you go at a constant speed the entire time? You don't speed up and slow down? Is there a change in speed? Is there a yucky, curvy path? You know what this is probably a job for? Conservation of energy. Even though it says work, I think I'm going to go like this. Kinetic initial, potential initial equals kinetic final plus potential final. And if they're talking about friction, you know what? The work done by friction, we've given that a name. We call it heat. Are any of these 0? Because at the top of your swing, you come to a stop for a split second. I think we're starting at rest. Why is potential energy not 0? Because where is initial and final in this question? The heights. Yeah, by the way, in the next question, we're at the bottom. Then you'll be right. But for now, we got that. Oh, this isn't so bad. To get the heat by itself, I think it's going to be potential energy initial minus potential energy final equals heat. Heat's going to be mgh initial minus mgh final. What did I say m was? 75 times 9.8 times 2.5 minus 75 times 9.8 times 2.4. Do that one in your head. Well, actually, I can factor out the 75 and the 9.8. So it's really going to be close to 750 times 0.1. It's going to be just below 774. 75, 75, you know what? It's A, right? Is it A? Yeah. Number 9. Hey, what if there was no friction? What would Tarzan's speed be at the bottom? Shaq, is there a change in height? Is there a change in speed? Is there a yucky, curvy path? And this question actually isn't saying find the work, it's saying find V. You know what this is a job for? Conservation of energy, G. Kinetic initial potential initial. You guys okay there, guys? Thank you. Kinetic final plus potential final. Does this question want me to include heat? No, it says ignore friction this time. Okay. Are any of these 0? Ending up on the ground. Starting at rest. So I get you know what else? Turns out for this question, not only would Tarzan be moving at whatever speed, Tantor the elephant would be moving at whatever speed, because it looks like... Shaq, what are we trying to find, kiddo? How would I get it by itself? And then? Yep. So, looks like V final is going to be 2GH square root. And I guess I should be fussy. Initial. It's going to be the square root of 2 times 9.8 times 2.5. I should be able to do this one in my head. 2 times 2. Does this work out evenly? 7 even? I'm getting square root of 49. Not 6.9, 7, right? It's D, not E. D. Written questions. Next page. I like number 10, I like number 10, I like number 10. I guarantee there's going to be at least one roller coaster on your test. How could I not? It's a great application. You've all, I think most of you at least, been on one. We're going to be going on some later on this year. So it's like a preview of coming attractions. This is like the Star Wars trailer for physics. Here we go. A roller coaster of mass 1,000, traveling with an initial velocity of 4 meters per second, is 18 meters above the ground. Drops to the ground, then climbs a 10-meter high hill. Got it. A, how fast is it traveling at the bottom? How could I handle this? Conservation of energy. So I'm going to go kinetic initial, potential initial equals kinetic final, potential final. Does this question want me to include heat? No? Okay. Are any of these 0? What about kinetic initial? Am I starting at rest this time? Okay. So this is going to end up becoming a half mv initial squared plus mgh initial equals a half mv final squared. Jordan, you been on a roller coaster before? Did you step on a scale before when you were on the roller coaster? Did they make you stand on a scale and weigh you? Yeah. You know why? Darn right. And again, I should, sorry, I got to be accurate here. If we include friction, it is true that masses don't cancel, but if I can make friction really small by greasing it down, it's not going to play a big role. Oh, you know what else I'm going to do? Jordan, I'm going to go times by 2, times by 2, times by 2, because that's going to cancel the 1/2 and the 1/2. In fact, what I end up getting is VI squared plus 2AD, except instead of A and D, A is 9.G and D is the height, equals V final squared. I derived that lovely kinematics equation. Get rid of a squared, square root. I'm going to get this. The final speed at the bottom of the hill is going to be 4 squared plus 2 times 9.8. Was the initial height 18? Wait a minute, Mr. Dueck. You're ending up below from where you started. Shouldn't you make it negative 18? No. Scalar, right? 4 squared plus 2 times 9.8 times 18 square root. Do you get, is the answer 19.2? Yeah. So you get 3 out of 3 if you got 19.2, and don't forget the units, meters per second. Otherwise, I would probably go something like 1 mark for that, 1 mark if I saw that, and then 1 mark for the answer. Something like that. B. How fast is it traveling at the top of the second hill? I think this is also a job for the law of conservation of energy. It's going to be KE initial plus PE initial equals KE final, PE final. Are any of these 0? Well, it depends. So you decided to have your initial be at the bottom, which is fine, but you're gambling that you got A right. Because if you got A wrong, then you're out of luck. I'm going to be a good test writer, sorry, and I'm going to use the info that they gave me. So I'm going to let initial be top of the first hill. I mean, see, that's nice, and it's a cleaner equation. So in many ways, I wouldn't have a problem with that. In fact, if I was rushed on a test, I'd do it your way because it's a time saver. I'd gamble, but we're not rushed. So none of these are 0. In fact, it's going to be, what am I trying to find? I'll get that by itself. It's going to be KEI plus PEI minus PEF equals KEF. Or if I expand, it's going to be a half mv initial squared plus mgh initial minus mgh final equals a half mv final squared. Conveniently, once again, and I'm going to again go times by 2, times by 2, times by 2, times by 2, because that's going to cancel out the 1/2. Oh, and then how to get rid of squared? Square root. I'm going to get V final equals big square root of V initial squared plus GH initial 2GH initial minus 2GH final. Okay, that's not on my formula sheet. Kind of cool. I can make it. I can work it. It's going to be V initial was at 4 squared plus 2 times 9.8 times 10 minus 2 times 9.8, sorry, times 10, times 18 is the first, 10 is the second. Is that right? I'm getting the numbers mixed up. I was trying to remember that. 10 and 18 that way. Times 18 minus 2 times 9.8 times 10. Okay. 4 squared plus 2 times 9.8 times 18 minus 2 times 9.8 times 10. Oh, square root. I was going, that seems really big. 13.1. If you get that, of course, 4 out of 4. Otherwise, I'd probably give you 1 mark for that, 1 mark for that, 1 mark for the square root equation, and 1 mark for the answer. Can you give yourselves a lovely score, please? On the top, out of 16, please.